Okay, now we're ready for problem number 4 on this assignment, and this one's a little different than the other ones. We're not going to be asked to find the empirical formula or the molecular formula. In fact, if you look at the beginning of the problem, it's telling me right out of the gate that it has the molecular formula given here at C33H35FN2O5. That's a big molecule. That's a huge molecule. They have amazing structures and all that. We'll be talking more about those later in the year, but what we're looking at here is a common drug known as Lipitor. And it goes by the official sort of chemical name of atorvastatin, and you see that here. Now, none of those names, Lipitor, atorvastatin, are words you have to be worried about understanding or remembering at all, but because this is a big ugly word we don't want to write out a lot, I'm just going to give it the abbreviation AV right out of the gates. So atorvastatin. I'm just going to take those letters and call it AV from now on, just to make our lives a little bit easier when we're showing our math. In this question, it's asking me a couple things. How many grams of fluorine would be in a 40 milligram tablet of Lipitor, which apparently is a pretty common dosage for this drug. So how many grams of fluorine would be in a 40 milligram tablet? And honestly, this problem is a very different one than all the ones you've seen up to this point, but it lets you start to see how we can do gram-mole conversions and whatever kind of conversions using things that we know, using the kind of organizational sort of structure we've been doing up to this point. And so what they're asking in this case is for the fluorine part of this molecule. So if you look at this molecule, it contains carbon, hydrogen, fluorine, which is the one we care about, nitrogen and oxygen, and there's only just a little bit of fluorine in there in that whole big molecule. And this question wants to know that about how much fluorine is in one 40 milligram tablet. Now, there's a couple places we could start here, but really what we're looking to do in any kind of problem like this is to find a number to start from. Okay? Start with some kind of a measurement or some kind of a quantity. In this case, we've only got one number to work with, and that's this 40 milligrams. So I'm going to go ahead and start off with that and say 40 milligrams of Lipitor, or as we called it, atorvastatin. So I'm just going to use AV as my abbreviation. You could write out the word Lipitor, or you could write out the word atorvastatin. Just for simplicity, I'm going to call it AV. So it's kind of like using X to substitute in for something much bigger than that in math or whatever. Now, we need to get grams of fluorine, but in order to get grams of fluorine, we also have to kind of figure out grams of this stuff that we're talking about and how much that is, okay? And build kind of work from there. So what we're going to do first here is we're giving a problem to start out here in milligrams, and milligrams are the unit that you commonly see in things like pharmaceutical drugs, because drugs are given in such small quantities that milligrams are the measurement unit that we use, not grams. 200 milligrams in like an ibuprofen or something like that. So it's a pretty common little unit, and it's one that we learned about in metrics way back in grade school and don't use a whole lot since. So the first thing I want to have you do here, and I would encourage you to do, is think about it in grams instead. And we know that there are 1,000 milligrams in a gram. Whatever I put in these boxes, and this has been the case up till now, should either be an equality statement or kind of a ratio statement. And we know that 1 gram is equal to 1,000 milligrams. So when I put them in the boxes top and bottom like this, and my milligrams cancel off, I know that 1,000 milligrams of atorvastatin is equal to 1 gram of that substance. And when I do that, my milligrams will cancel off, and I'll have grams. So if I punch this into my calculator right now, I would have a value for how many grams of atorvastatin are actually here. I'm going to go ahead and do that for this problem. We could continue on and actually string together several conversions at once, but at this point we're going to go ahead and do it. Now, if you need to punch in your calculator, you go ahead. If you're good at moving decimals and stuff, you should do that. Feel free to kind of shortcut whatever you can. But this turns out to be 0.0400 grams of atorvastatin. Okay. And again, 40.0 over here has three measured values, so I want to make sure that my value here still has 3. And again, more on sig figs to come. But right now, all I've done is convert my 40 milligram tablet to a 0.0400 gram tablet. Why was that useful to me? It turns out that much like the problems we've been doing up to this point, we're going to want to do some conversions to moles here, work with moles here. What we want to do is think about in this compound, C33H35FN2O5, there's some of each element, some carbon, some hydrogen, some fluorine, some nitrogen, some oxygen. And the sum, the part that we're interested in here, is the fluorine part of it. So what we can do is sort of set up another conversion here. And what we can do, when in doubt, now let's say convert to moles. When in doubt, it's probably a good idea to get to moles. In this case, it turns out you could actually skip over the getting to moles step, and eventually I'll want you to move toward being able to sort of combine steps together. But I think I'll have you do in this problem and encourage you to do in this problem is go ahead and convert to moles, because again, when in doubt, convert to moles is a really good rule of thumb. And if you can see it work a few times or get you moving in the right direction a few times, it might be a useful thing as we move forward in the year. So I'm going to convert this to moles. 1 mole of atorvastatin is how many grams of atorvastatin? Now here's the deal. I can't go to my usual periodic table and look up atorvastatin like I've looked up carbon or nitrogen or bromine or hydrogen on the other problems, because it's not on here. But it kind of is, right? Because this compound's formula is known to us. We can add up all these elements off the periodic table and we'll have the mass of the molar mass of atorvastatin. So I'm going to go to my calculator and start adding those up. I need 33 carbons. So 33 times, oops, hopefully you remember, 12.01. That's 33 carbons. Plus, I need 35. I keep missing my key here, sorry. 35 hydrogens. Plus, I need 1 fluorine. Now, that's one we haven't used up till now. So maybe we better jump back over here and make sure we take a quick peek. Fluorine on the periodic table has a mass of 19. Okay, so I need to add in that oops, I'm going to go back to my formula. I need to add in that 19 plus I need let's see, 2 nitrogens, so 2 times 14.01, and then I need 5 oxygens, so that's 5 times 16. So that's all those elements added all up. And according to my math here, it's got a molar mass of 558.63. That's a big molecule. Bigger molecules have huge molar masses. Now you can go back and double check this. Some calculators will show all the text on the screen at one time, others maybe won't. It wouldn't hurt to go back and just double check that you've put everything in correctly. I did this number earlier, so I know this is correct in this case. But you might, probably the bigger the molecule, the more likely it is that you want to go back and double check. But that's my molar mass, so 558.63 grams in a mole. Now look, we're only using 0.04 grams in a tablet of this compound. And there's 558 grams in a mole. So we're nowhere near a mole of this stuff. A mole of atorvastatin would be enough to, be all the Lipitor you'd need to take in whole lifetime probably. So in this case, we're not going to be anywhere near a mole. So when I divide this out, grams will cancel out, and my calculator is going to give me a very small answer, right? Because we're talking about a very small number of moles. But go ahead and let's punch it in anyway. So I have 0.04. Oops, divided by 558.63. Now, that's my answer for moles of atorvastatin. And it says it's 7.16 times 10 to the negative 5 moles. Now, don't be afraid of powers of 10, because they're going to show up all over the place. Don't be afraid of negative powers of 10. Feel free to use them as they are. But this does represent an actual number that looks like a kind of regular number, if you will, that's not written in powers of 10, right? This is actually 0.0000716 moles, if you really prefer that. But at some point, you need to get comfortable with using scientific notation, because in chemistry, we work with huge quantities and we work with tiny quantities. And in both cases, scientific notation is the only way to go. Now, we're not quite there just yet. Okay? We're not quite to the end. Because what we want to do next here is figure out how much of that is fluorine. Okay? How much fluorine's in that tablet. But if you're peeking ahead, you've actually noticed perhaps that question B asks how many moles of the drug are found in the tablet? How many moles of atorvastatin are in the tablet? We've just figured that out. And you'll notice in chemistry occasionally with the AP problems that a later problem actually asks you for something that you earlier figured out already. And in this case, that's happened to us. So we've actually got our answer here already for part B. It's 7.16 times 10 to the negative 5 moles of atorvastatin. It's really important to notice that labeling your answers can be a huge benefit to you. Because if you didn't label this answer, and we just had 7.16 times 10 to the negative 5, you might not even realize that that's an answer that's going to be the part B result that we needed. And you might later on find yourself redoing a bunch of things because you didn't label your work. So make sure you do. Now, how am I going to get this 7.16 times 10 to the negative 5 to be into the right substance and the right units? In this case, grams of fluorine. Well, it's going to be one more conversion, and I'll show it to you here. If you haven't already noticed the pattern and all the problems that we've done up to this point, whatever units you have to start the problem, milligrams, tends to be what you put in the next box down below so that that unit cancels out. And this next problem we did at grams of atorvastatin canceled out with grams down here. We're going to do the same thing here whenever we can. Now, it won't always happen like that, but dang near always, that's what's going to happen. And you're also going to find that very, very frequently, in front of the word moles will be the number 1. Not all the time, but it will work here again. Because in 1 mole of atorvastatin, which again, remember, has this big, big compound shape up here, this big molecule. In 1 mole of it, how many fluorines are there? How many fluorines are there in 1 unit of this stuff? Well, we know that that whole big molecule has a mass of 558.63. And I got that big mass, 558.63, remember, earlier by adding up all the molar masses for all the substances involved. Now, on my calculator, I can go back up here to that line, and probably many of yours you can do the same thing. I can go back up to that line and see that in that big string of numbers we added up, there were, let's see, 33 carbons. There they are. There was 35 hydrogens at 1.008 each. There was 1 fluorine there, that 19. There was 2 nitrogens, and there were 5 oxygens. All right. But the one we care about is the fluorine. So how many fluorines was there in that 558.63? Just 1, right? If I go back over here in my numbers, I can see that there it is. Okay. There's that 119 in the middle of all those numbers. That's my 1 fluorine atom. So that means that out of this 558.63, that's a big molecule, only 19 grams of that 558.63 is from the fluorine. And that, recognizing that, saves us any more math, because right now I can go over here and say that in 1 mole of atorvastatin, which is 558.63 grams, there are only 19 grams of fluorine. Now, there's how much nitrogen? Well, there's 28 grams of nitrogen because there were 2 of those. And there's 80 grams of oxygen because there's 5 of those. And there's a whole bunch of carbon. I won't try to mathematically pop that one out my top of my head real quick, but there's a lot of carbon. And there's some hydrogen in there too. But we're interested in the fluorine here. And out of that big 558.63 we added up, only a sliver of it. If you think about it like a pie chart, only a sliver of it is the fluorine. And that 19 is that little sliver out of that we're interested in here. So for every 1 mole of atorvastatin, there would be 19 grams of fluorine. But we don't have anywhere near a mole, remember? We're working with a tiny tablet. And so if we punch this in, 7.16 times 10 to the negative 5 times 19 will tell us how many grams of that is fluorine. So let's punch it in. 7.16, let's see, times 10 to the negative 5. And then times 19, just like that. And that's going to be our answer in the end. 0.00136 grams of fluorine. And again, the way I know the units work out is because these moles cancel these moles. And grams of fluorine are the unit that's left, and that's what plops in over here. Okay. So in one tablet, which is what the question said, there's 0.00136 grams of fluorine involved. Okay, and for question B, how many moles are there? We'd already found that earlier, so we don't have to do any further math. In fact, if you showed your work and labeled it, you could get credit for having it up above and having found that answer. I'm just going to make a little note here that says C part A, so I can remind myself where I came up with that if I was to look back at my work later on. Okay, so a couple different things that we did in this problem than what we've done before, but really what we had here was a metric conversion. We had milligrams turned into grams, metric conversion. We had a grams to moles conversion, which we've done a bunch of already for elements. We haven't done a lot of them for compounds on the problems on this page, but if you did the earlier homework or you looked back at it from last year, it's familiar hopefully to you. And in this last step, we found a way to say that for every mole of a substance, some little part of it, just 19 grams of it in this case, was the interesting element to us, and that was fluorine in this example. So that's one way to look at this problem that's different than the ones we've been doing, but really with conversions that are sort of along the same lines. Gram-mole conversions, mole-gram conversions, relating a substance to one of its specific parts in this case, plus a little metric conversion in there at the beginning. Now, if you've been paying attention, you'll know that there's this formula sheet, right? we've been looking a lot at the periodic table, but there's also this formula sheet that if you got the AP assignment, you should have a copy of. If you didn't get the AP assignment picked up, then it's posted on Google Classroom for you to take a look at too. And again, you can just Google AP Chemistry formula sheet, and it should come up for you. But there's a whole bunch of formulas on here and constants and all kinds of things. But what you'll find are some things that you might not know aren't on here. And at this point, we haven't used milligrams and grams since forever. So if you're not familiar with milligrams and grams, and we used that ratio earlier, maybe make that a little list you should be starting on a separate page in your notes, or maybe just some place that you can keep track of it, so that you remember that 1 gram equals 1,000 milligrams. And this is a list of some of those constants and conversions and little notes to yourself that maybe you want to write down somewhere, or even just start programming into a file in your calculator if you know how to do that, because you can have a list of extra little notes to yourself in your calculator for the exam, and it's perfectly acceptable. For now, at least maybe start a list of those things so you've got them someplace. If you don't know that conversion off the top of your head and aren't comfortable with it, put that on the list, and let's start with that. Okay, so that's question 4, and I'll come back with questions 5 and 6 on the next video. See you then.